Hello everyone, how is everyone doing? My name is Georgianna Lynn. This work on head-room display positionings was performed while I was at Georgia Tech, and I want to thank ISWIC for this opportunity. Many AR device manufacturers are trying to create a device that has the form factor of a pair of eyeglasses. Due to the heavy optics required for a larger field of views, manufacturers who want to keep the form factor of eyeglasses are forced to make devices with smaller field of views and must decide where in the visual field to place the virtual image. Dividing the visual field into a 3x3 grid with the center being in line of sight, here are some of the design choices manufacturers have made in the past. Are some of these designs better than others for on-the-go tasks? Well, most smart glass designers seem to believe that their users will want the display in line of sight. In fact, when first given a head-up display, pilots and drivers prefer a in line of sight position and seem to have the best performance as well. However, with experience, they quickly move the display out of line of sight. Why? Well, imagine if this image popped up while you were driving or flying. Research by the aircraft and car industry suggests that the in-line of sight position might lead users to pay more attention to the head-up display than the physical world. Managers and industry worry about similar situations, which limits a head-worn display's usability for tasks while on the go. So, if not line of sight, where is the best place to put a display? In our first experiment, we created a simple button pushing game to determine how far towards the ear we could position a display before users are uncomfortable. We test more extreme horizontal offsets than previous studies with the four conditions 0, 10, 20, and 30 degrees. Note that these numbers are the center of the display, so that the 0-degree condition has pixels between plus or minus 5 degrees. There were 12 participants in this within-subject user study, and we measured the time and accuracy in which they completed their task. We also had them create their comfort level on a 1 to 5 scale, 1 being the least comfortable, and they used this knob to indicate their comfort. They also indicated preference, eye strain, and workloads through surveys such as NASA TLX and Likert scale questionnaires. During the game, a head-worn display is used to indicate which button a player should push on a 3x4 shelving array. On the left here is what the user would see on their head-worn display. In this case, they would push the button in the second row from the top and in the middle column. During the experiment, participants are also asked to turn a knob into positions that correspond with their current comfort level every 5 minutes or so. While task performance was similar across all conditions, we found that 0, 10, and 20 degrees were more visually comfortable, preferred, and likely to be used than 30 degrees. 10 degrees was preferred by users over all other conditions. 0 degrees and 10 degrees was also resulted in less eye strain than 30 degrees and 20 degrees. From study 1, we determined that a 30 degrees offset could probably be eliminated on the grounds of user comfort. With these results in mind, we decided to isolate conditions to below 20 degrees or so offsets horizontally for a second study. Additionally, in study 2, we put our participants in a real-world task that currently has significant industry impact. Order picking is the action of retrieving products from storage, so like a warehouse, given a customer's request. It is currently one of the most successful usages of head-worn displays and one of the most well-studied. In study 2, we looked at 4 positions below 20-degree horizontal offsets, 2 vertically in line of sight, so center, center, and center right, and 2 vertically below, bottom center and bottom right. We chose these 2 vertical offset positions because these are the most popular vertical offsets considered by manufacturers today. Users in study 2 performed a real-life, on-the-go order picking scenario with actual pick items. During the experiment, each participant would pick a total of 10 items off of a pick path and do 5 pick paths per condition. To locate an item, they had instructions graphically displayed to them on a head-worn display. There were 12 participants, and we measured the speed of picking an item off a shelf, accuracy of picking that item, workloads, and preference on these 4 positions. For our experiment setup, we imitated a warehouse. So our warehouse consisted of 7 bookshelves labeled A through G, seen on the left here. Each bookshelf then consisted of 5 rows and 3 columns with items. These were 2 screens that the user saw, called Environment View and Shelf View. Users could toggle between the screens to first determine which shelf the item was in and then where on the shelf the item was on. Surprisingly, center right trended faster than all other conditions, though the results were not significant statistically. Center right and bottom right were less accurate than center center. Bottom right had twice the errors of center right. Users also ranked center center better than bottom right for speed, comfort, and learnability. Both experiments confirm results of other studies that center or in line of sight devices can be desirable and comfortable. However, when in line of sight is not a viable option, such as tasks where it would pose a safety hazard, both experiments also seem to indicate that a horizontal displacement towards the ear, center right, for a head-worn display might be a valid alternative. Bottom center is also a strong contender. However, vertical offsets underneath in line of sight might be tricky when negotiating stairs. Bottom right seems undesirable based on performance results. So ideally, the best case is a head-worn display that allows a user to adjust the active visual area as desired to support the task at hand. However, we also recognize that adjustable mechanisms on these devices currently can be quite heavy and uncomfortable. If such devices are not possible, we recommend placing a display in the horizontal field of view between 8 degrees and 20 degrees towards the ear. Future work should further explore both horizontal and vertical offsets during different types of tasks, as well as with new updated devices as hardware continues to improve. So thank you for your attention. Any questions?